In this lesson, we're going to work with graphic screens. Excuse me. We have a lot to cover, so I think we'll get it done in two parts, but we need a lot of understanding here. What we're going to do is look at all these bit patterns we can set up for screens. Currently, Extended Basic excuse me, gives you 4 screens, H screen 1, 2, 3, and 4. But there's over 20 possibles we can get. And here we're going to review these various bit patterns, and we're going to look at all the different screens and bit flavors you can get. Pixels, width, color, 16, 2 or 4. We'll look at all that. We'll also look at the way Extended Basic sets everything up, and we will take a look at our code and see how we can mimic what Extended Basic is. So we have a lot to cover. So with that, we're going to do some reviewing first. Okay, we had passed. So the last thing we did in lesson 9, we looked at our 128 stars moving in all directions. We used Basic to do a lot of the heavy lifting for us. We used the H screen 2. We did a jump subroutine to task 1 and task 0 to select what we were doing. And we also used Basic for get character. I need to back. That was in lesson 8. I'm sorry. In lesson 9, we did the keyboard routine where we didn't have to use get character. So in lesson 9, we figured how we could get around by using Basic for that. We're going to review the MMU and the task again, and then a lot of graphic screen parameters. A little bit more review. Remember our MMU registers? I know we've been over this 2 or 3 times, but it's very, very key to the heart of the system. So bear with me. I'll refresh. Okay, task 0 uses registers A0 through A7. Okay, task 1 uses A8 through AF. Okay, again, this screen, you're probably tired of this, but when you turn the system on, this is what you get. Here's your addresses over here. These are relative addresses. These aren't real addresses. They're relative. That's what you see when you at your program. If you see something at A00, this is what you're looking at. And here's the memory blocks that is used. 3.8 through 3F. Okay, that's task 0. If you pop the run register, it says give me task 1. This is what you get. Here's all your relative addresses, but this is the blocks you got. You got 38 is still there, 3D is there, and 3F. You're going to get 30 through 33, which is by default where the graphic screen is, and this is a work area, okay, that Extended Basic uses. So problem that we're going to have, or we don't have, but just think about it. What we've been doing is programs, small programs, just display a little bit of this, a little bit of that, no heavy load program. And down here in the 0, most of our programs we loaded it are E00 or F00 or 1000, and they're short programs like the 128 stars. That program was only like a hex 200 long, just say about 500 bytes long for the whole thing. We had no background, no sprites, just some stars running around. So most of our programs are very small. Now, let's assume new program is going to have some backgrounds, some sprites, and a lot of code. So if I go back up here and we load it in, we say we'll load it in at 1000, but let's just say that it ends down here at, let's use either 2500 hex or 3000 hex. So we load it in down here in blocks 38, 39. We load a program, it would be just say from here up to the middle of FFA1. If we pop that register, bang, that would overlay our program. So we've got to figure out, we're going to tell you how to do it. We can't bring our screen in to manipulate in this area here because it just overlay our program. So if you were executing something, you'd jump in the middle of the screen, you'd be hung immediately. So a couple ways around it. One is change the task 1 registers and push it up the four blocks where the screen is located up, and then we've got our program would fit and we could execute it. And we'll back up one. When it's in this area here, the 3031 is down here at this level. Color basic is still in there, so we can still use get character, because that's one of the few things that does work in this mode. Get character will work. But once we pop it up there, color basic is gone, so we have to use the N key. That's why we learned it last time. So we're going to move this thing up. We'll be able to still read a character off the keyboard. Another option is if you use a different screen configuration, resolution, and one I use most of the time, because most of the stuff I write is not big stuff. I just do a lot of my own stuff for my own fun and their experimental stuff, and I use 256 pixels across, 192 high, with 16 colors. That will fit in 6,000 hex bytes. Okay, so that's 3 blocks instead of 4. And so that's where I can just use showing here, I can use it in 3 blocks in here instead of 4. I could write a program that would fit in here and still have color basic if I wanted to, but I'd go either way. But anyway, that's just another option, and we'll see when we look at these various screens. Some of them only use 1 block. If you get down to some of the lowest resolution blocks, you only need one block. So we will move on with that. More review. I just need to make sure we understand this formula, okay? And one of the experimental things I did was not part of this lesson, but something else I put out there, was using multiple buffers for animation. We got buffer 1 and buffer 2 here. All right, there's standard off the shelf when you boot it up. The graphics screen is located in blocks 30, 31, 32, and 33, as we just seen in the previous slides. And the real physical address, it can be calculated by taking this first block, hex 30 times hex 2000 and divided by 8, will end up with the real physical address of C00. That is not this C00 here. These are relative addresses. This is the real actual physical address. In fact, if you look over here on the left, go down here, we got block 0, and that goes all the way up to block 3F. And if you multiply that out, all them blocks, it comes up to 512K of memory. But this is the real physical addresses. So if we got working with 2 buffers and we're using, just say one of them's down here and starts at 28, you could put 28 in this formula and it would come out to A00, real address. Likewise, 2C comes out to B00, real address. But that shows you can have the screen, because the MMU just needs to know an address where them 4 contiguous blocks are going to be. You could put it down here in 000, use 0, 1, 2, and 3. Put the 0 in the formula. 0 times 2000 is 0, divided by 8 is 0, and your answer would be 000. You plug that in to the MMU, and that's where it would display the screen from there. So you can have many, many screens in that. Okay, with that, let's look at some of the other things. Start with graphic screens. I don't want to get these too long. All right, this here's a you can use an include file, or you can just use it. I originally wrote it as an include file, but I don't include it anymore. It's an awful lot of stuff. But it has a lot of equates and a lot of things down here. It's going to have all of our screen settings. We'll go briefly. We'll look at this and we'll review it in the part 2 of this for sure. We got a lot of things that are in here. Okay, the VSync register up here. That's register that tells when the screen is just finished. It's complete writing, and it's before it starts back on the top lines. Here's some of the task 0 registers. Oh, I'm sorry, that's this one here. This one here is the interrupts. There's 2 sets of interrupts. One is one of them I call the CPU interrupts, and the other one I call the MMU interrupts. I don't know if the correct name's for them, that's why I call them. This here is for all the MMU interrupts, the IRQs and FRQs that are in the MMU. This FF91 here is for task 0 and task 1. And these are a lot of this over here, this notes that I just put in here for me for remembering their remarks. If bit 0 is off, you're in task 0. Okay, and this should have your same what we've seen in the other slides. This is what the blocks that would be in there. If you store this here with this bit, lowest bit on, you get, there's task 2. Again, this is notes. This is the ones I normally use, so just was my notes. Of all the stuff, and here's the stuff, the main ones we're going to use is right here. The video mode register, the video resource register, the border register, video start address, and hard offset register, which we don't really use, but this is what we're going to use this section. The rest of this is, well, it's for interrupts, which we're not going to talk about interrupts now. At some point later on, we'll talk about interrupts, fast interrupts, software interrupts, and etc. We'll talk about that later. Right now, I'm going to do this part here and break away from this and come up, excuse me, in part 2. Here's a high resolution. If you want to break it down by bits, and you can find this all in the Unraveled Basic or a lot of other documents out on the internet. And what it's saying here, if you look at this here, this bit patterns, and this here in these two bits here would be the number of rows displayed on the screen. If it's 00, it'll be 192. If it's got a 01, it'll have 200, and if it's got a 11 in there, it'd have 225. The other one is if it's got a 10, it says undefined 0. I have no idea. I'm scared to even try that, but you can have that many rows across the screen. Now, here's a different graphic screen you could have. Okay, and normally you'd see here's the for the 32 character screen, the 40 character screen, 80 character. You can have a 64-bit character screen if you care to try it, and the 128 or 160 bytes per row. And our colors, you can have either 2, 4, 16, and again down here undefined. I would know what happened if you did that. Okay, this is probably too much to get into now, so I think we're going to cut this off here, and we'll come back in and look at the program and other pieces of this. This concludes part 1, so now move on to part 2. We'll finish up the explanation of all of our graphics screens.